Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 2 from the February-March 2024 paper 2, IGCSE Cambridge 0580 paper. And this question here is about angles and circles and similarity. So it says A, B, and C and D are points on a circle. ADX and BCX are straight lines. These are both straight lines. Angle BAD is X, and angle DCX is Y. It's telling us to explain why X equals Y. Give a geometrical reason for each statement you make. Okay, so Y is X equal to Y, all right? And the reason being X is equal to Y is because you can say that you have here X is equal to Y. Let's see the reason why why X is equal to Y. Okay, we have here a cyclic quadrilateral. It's not a tangent. This is not a tangent to the circle here. Okay, it's not the alternate segment theorem. Some people might get confused by this because BCX is not a tangent to the circle. But what we have here is ABCD is a cyclic quadrilateral. So the first step we can say ABCD is a cyclic quadrilateral. Okay, and angle BCD is equal to 180 minus X. Okay, so what I'm going to do here, I'm going to do a little table, which it's not really a table, but I like to set my work out in this way so that everything becomes nice and neatly laid out. So I'm going to put statement. So I'm going to make a statement, and I'm going to give the proof for it. I'll put reason. The reason is the proof. Okay, so first of all, I'm going to say that angle BCD is equal to 180 minus X. Okay, why? They're opposite angles in a cyclic quadrilateral. They are supplementary. That only works for a cyclic quadrilateral, right? Where all four of the corners are on the circumference of the circle. So I can say that angle BCD is equal to 180 minus X. So BCD is equal to 180 minus X. You can say opposite angles in a cyclic quadrilateral. Let me write that a bit neater. Sorry about that. My handwriting is terrible there. So opposite angles in a cyclic quadrilateral. Okay, still not that good, but anyway, it's not bad. All right, so BCD is 180 minus X, and we can say that BCD plus Y, okay, equals 180. Okay, or we can say that Y is equal to 180 minus X. Okay, why? Because they're on a straight line. So we can say Y is equal to 180 minus X. Y, you can say angles on a straight line. The angles on a straight line, they add up to 180. So we can say, therefore, that you have 180 minus 80 plus X. Okay, that's going to equal X. So therefore, Y equals X. Okay, Y equals X. And we've got the answer to question 2A. All right, so we talked about angles on a straight line and opposite angles in cyclic quadrilateral. Those are the reasons for the statements that we make and the answers that we got. Okay, now for part B, it says show that triangle ABX is similar to triangle CDX. Okay, so again, I'm going to do the same thing. I'm going to have statement and reason. So we're talking about similarity here, statement and reason. So I have ABX. So I'm going to make a little sketch of this triangle. Oops, what happened there? Strange. Oh, I did something silly. 1 second. Just have to sort this out. Okay. All right, that's better. Okay, so I've got this triangle here, and I've got this triangle over here, which if I copy and paste, okay, and make it a bit smaller. Okay, so I have this triangle ABX, and I have this triangle, which is basically, I'm going to draw the same way or the same orientation as ABX. So this is ABX. I'll make it a bit smaller here so I can have more space. And this is the triangle which is smaller than ABX, which I'm going to just draw. So I draw the two triangles, the same orientation. Okay, so they look the same. Okay, so I've got here ABX. I'll put here ABX. Now I know that this angle is X. Okay, so here I have this triangle. I know that this angle is also the same as X. This is Y, which is the same as X. So these two are the same. So this angle and this angle are they both the same. We can in fact call them both X. So this is now X as well, as we know from the first part. So these two angles are the same. I also know that AXB is this angle over here, and so this is where angle A is. Okay, AXB is this angle over here. So let me just do this a bit more clearer. This is angle X. This is also the same as angle X. Okay, and this is angle AXB, which is the same as this angle here. Okay, this angle, so it's basically the same angle as CXD. These two angles are the same. Okay, so what I can say here is angle, so that means this must be X, and the small triangle, this must be, this is not A, this is C, the small triangle. So this is C, this is X, and this must be D. Okay, so in the small triangle, this is where X is C, where the small angle X is C, where the side, or the point X is the same as this X over there in this triangle. They're both the same. They share that same corner. And where this angle D is the same, basically, it's the same as this angle over here. These two angles are going to be the same. Okay, so these angles are going to be the same. Okay, how do we know the same? Because of the fact that I know these two are the same. These two must be the same as well. Because if you know two angles are the same in a pair of triangles, that means the third angle must be the same because they add up to 180 degrees. To 360 degrees in total. So we can say that angle DCX is equal to angle BAX, and that's given in part A. All right, so that's what we proved in part A. Okay, and then we can say that angle CXD is equal to angle AXB. Why? Because they are the same, the same corner of the triangle. Okay, they're basically the same angle. All right, so therefore we can say that triangle AXB is similar to, so similar is given by this kind of symbol over here. You can just write the word similar to triangle CXD. Okay, why? Reason, angle. So therefore we can say that angle CDX, that's it, that's what we have to say. That's it. As long as we don't have to prove the other angles are the same, okay, we can just state that, that's fine. So we don't have to show that. Of course it's got to be the same. All right, so we just have to show that two of the angles are the same, and that proves that they're similar. Okay, so therefore they are similar triangles. So this is the proof that they are similar triangles. Okay, that you've proved that this angle is the same as this angle, and this angle is the same as that angle. That we found in part A, and that we can tell because they're the same corner. Simple as that. Okay, so there's the answer to part B. Now for part C, it says AD equals 15 centimeters. So from here to here is 15 centimeters. It says DX equals 9 centimeters, so that's 9 centimeters. CX equals 12 centimeters, so 12 centimeters from there to there. Find BC. Okay, so again, I'll take this triangle. This is the big triangle. Make it look a bit smaller. All right. And I'll take the small triangle, which is kind of like this orientation. In fact, I'll keep it the same orientation for now. So I want to work out some lengths. So I'm just going to take this triangle and the small triangle, draw them a bit smaller than they actually are, so I've got space to work. So basically what we have, this represents triangle A, B, X. This represents triangle. And now remember, A was the same as C. This is X and this is D. Okay. Now we know that A to X, this total length from there to there is 24 centimeters, 15 plus 9, so that's 24. And C to X, that's that length over there is 12, so that's 12. Okay, I know that the D to X, which is this length over here, is 9. And we want to find that the length B to C. B to C is all the way across from there to there. So I need to find B to C, which is this length over here. Okay, this length B to C. Now, B to C, as we can see from here, B to C is going to be B to X minus C to X, which is B to X minus 12. So if I can find the length from B to X, which is represented by this length over here, okay, this length over here, BX, then I'm going to get my answer. All right, so what I can do here is I can use similarity. I know that B to X is equal to, now what's corresponding to B to X? 9. But B to X is bigger than 9, so I'm going to do multiplied by 24 over 12. Okay, so it's going to be 18, because 24 over 12 is 2. All right, so, the ratio of the lengths is basically, doubled. This small triangle to that is doubled. So if you this is 12, this must be 24, this is 9, this must be 18. So therefore, B to C is going to be B to X minus C to X, which is going to be 18 minus 12, which is 6 centimeters. So that's the length from B to C. That's 6 centimeters, because the total has to be 18 here. Okay, so it's a case of drawing them with the same orientation, working out which length fits with which length, and then working out what you need to work out. So that's part C part 1 done. Okay, and then it says complete the statement. The ratio of the area of triangle ABC to the area of triangle CDX is, well, we know that the ratio of the lengths, okay, is 2 to 1. Okay, the bigger to the smaller. The ratio of the areas is going to be the square of the ratio of the lengths. Okay, so that's going to be 4 to 1. The ratio of the areas is the square of the ratio of the lengths. For a 3D shape, the ratio of the volumes is the cube of the ratio of the lengths. So the ratio of the area of ABX to the ratio to the area of triangle CDX is going to be 4 to 1. That's an important point we need to know. So there's the answer to this question, number 2, from the February-March 2024 paper. I hope that was clear. Thank you for watching. Other questions from this paper will be found in the playlist that will appear in this section over here. Other questions which deal with, I guess, what did we talk about? All right, angle geometry of circles, you can find in the playlist over here. I'll also have a playlist here which deals with similarity. Okay, and similarity, that includes the ratio of the lengths and areas and so on. So you'll have some playlists there which you can use. You can find other questions similar to these types of questions, and you can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.